Hi, my name is Connor Thomas. I'm a second semester junior in the mechanical engineering program at UNC Charlotte. For the past 2 semesters, the spring and summer of 2020, I was interning with this company called Oerlikon Additive Manufacturing, and I was there for a total of 8 months as an engineering intern. I learned all the ins and outs of this business, and basically, if you haven't heard of Oerlikon, they're a 3D metal printing additive manufacturing plant that makes metal parts for aerospace companies. Primarily aerospace, also different industries, but primarily aerospace as of right now. While I was there, the primary department that I got involved in was quality control. So I was under the supervision mainly of 3 different employees, and one of them was the supply chain manager, one of them was the quality assurance technician, and the third one was a quality control technician. So while I was working, whenever I first got there, I didn't really have an exact role assigned to me, primarily being because I was the first co-op student that Oerlikon has ever had. And so I think they were, and this was also my first co-op experience, so I think they were trying to figure out the right way to do things for a co-op student, and I was trying to figure out what's expected. And so when I first got there for the first couple of weeks, I was basically maintaining these spreadsheets that keeps track of all the chemistry that is in the metal powders, and I had to make sure they were abiding by the specs and making sure they were good enough metal powders for us to put on the printers. So after I did that, they gave me a little side assignment for a week where this other company called Oerlikon Medco, they needed a atomizer for making these metal powders, and we had a physical model of it at our site in Huntersville, but they needed a CAD model of it. So I got to reverse engineer this atomizer that you're seeing in the right here. I started out taking a contour line with a CMM machine to get the contour of each of those parts, and then basically creating it, reverse engineering it, like I said, into a CAD model. So this was sent over to another Oerlikon site. They were over, I believe, located in Germany. And so that was pretty cool, very cool experience. And I learned a lot of SolidWorks, of course. After those assignments, I began to inspect parts with, I don't know if you guys know, but what a GOM scanner is, or what a CMM is, or profilometer, which is used to like measure roughness of surfaces and whatnot. So I was doing a lot of inspections. While I was there, I got some insights. So mainly learned about the different businesses that Oerlikon works for, or the different companies that Oerlikon does business with. I learned about ITAR and ASTM standards. Both of those things are very critical when it comes to aerospace because one, ITAR, that keeps things and knowledge within the United States. You're not allowed to share it with any kind of like foreign people, I guess you could say, like someone from another country. It's against the rules. So I had no idea about any of that. I thought that was pretty cool to learn about. And the ASTM standards, that there's pages and pages of them, but those are also all weaved in and out of the aerospace industry. While I was there for those 8 months, I helped the company by generating these reports, which I'll show you in the following slides. And these would show basically the quality of the parts, the profile of them, if they were within the tolerances specified by the companies. And then also it provided information for the machinists so that they could do the additional subtractive manufacturing that needs to be done after a part was completely printed. And also the engineers, because they're the ones who load the CAD files up using like Magix software to upload the part to the printer, and depending on how they orient the part in the file, in the Magix file, that will determine like how the part will morph and shape as it's being printed. So seeing all the profile analysis and the dimensional analysis of all the parts after printed gave the engineers a better idea of like how their orientation affected the final result of the build. So like I said, I generated reports, and this is an example of one of the reports that I would do. On the left-hand side, that picture right there is what a GOM scanner looks like. So it takes a picture of whatever part you're putting on that little plate where you see there's a box over it right now, and the reason for that was like ITAR, so I'm not allowed to tell that information or show that to anyone. It's like a big no-no. So that's the reason for the box, but usually there would be like a part underneath there, and this GOM scanner would take pictures of it, take pictures of the part as it rotates in like 360 degrees, and it would end up creating this CAD model that you see in the picture in the middle. So that was like a visual representation of whatever the camera captured as it went around and took pictures. Now that's not a very long process. The longest part of this process is the picture on the very right where you're doing these surface comparisons. So the companies, whatever company or customer the part was built for, they would have a profile tolerance on their CAD drawings. We would take that profile tolerance and we would break it up into that color-coded bar that you see on the right side. And that shows how much plus and how much minus the overall profile of the part is compared to the profile tolerance specified on their prints. So that information became very useful for, say, like I said, post-processing for the machinist, because if they have to do subtractive manufacturing on it, they need to know how much material they need to take off, how much stock is left. And for the engineers, depending, you can see how like on the lower half of that picture on the right side, it's like a dark blue, and it says like minus 22 thousandths, and then on the other side it's plus 15 thousandths. So that shows that there's some like morphing going on during the printing process. So that's useful information for not only machinists but also engineers, and the customers really like seeing that to see like the quality of whatever we're producing. Here's another one. Before that was a GOM scanner that I showed you. This is a CMM, which basically goes around, and it's like a touch probe. If you don't know what it is already, it goes around and touches off and gets the dimensions of whatever part you're scanning. So like you put it on the center of that big plate, and then the big machine, let's see if I can draw, like this would have a little probe attached right here, and then this would like swoop around and touch off everywhere, and then that's how you get to generating these reports that you see on the very right side. These reports tell you the dimensions of like the top diameter, the bottom diameter, the inner diameter, outer. So it's mainly taking like a 3D image, and it makes it into two-dimensional measurements, and then we send that off to the customer, and we show them like, hey, look, the part, it's within specs that you specified, we're all good. And then whenever it wouldn't be in spec, it pops up in red, like you see right here. Top diameter, top OD diameter, it's in red, so it shows that it's out of tolerance by like 2 thousandths. So it's very small, and most of the time, if it's not too bad, then you fix it, and this is where you decide what you're going to do with the part before actually giving it to the customer. So this is also very useful information for machinists, customers, and engineers. So the pros and cons that I experienced while I was there, like I said, I didn't have an exact role when I first arrived, but I don't pin that on Oerlikon or anyone. I know, because like I said, I was the first real co-op student they had, so just sort of like getting a groove, getting in a groove with each other. And I didn't feel challenged because, like I said, I was just on Excel for the most part, just for the first couple of weeks. And The engineers, what they do was completely different almost than what I was doing. Not completely different, like my stuff was crucial for what they were doing, but the engineers focus more on uploading those CAD files onto the printers for them to produce the parts. I was on the back end at the final stage of it where I would check to make sure that what the engineers did was correct. So it was cool what I was doing, and I have no complaints from it, but I think it would also been cool to learn about what they did a little bit more in depth. So pros, there's a lot more of these. So I learned the entire manufacturing process all the way from start to finish. Even though I was starting out just doing Excel, logging Excel data, that was all a part of like the chemistry and the preparation of the powders prior to the printing. And then I got to see what the printing process was like and how I saw slightly how the engineers would upload their CAD files just from me going out and like, hey man, like what are you doing? Like just trying to learn, learn from them a little. And same thing with the machinists, see what they do whenever they remove support from the build, because a lot of the builds they have to have like a little mesh support material to keep it from like collapsing under its own weight during the building process. And also quality inspection, obviously. I learned how to use a golem scanner, which I don't know if you guys have taken the class called Advanced CAD, but I took that prior to working here, and our final project was to do a golem scan of any part of our choice and then create it into a CAD file. So I already had prior experience with that, and then I just went like and mastered it by the end of it, just because I was so deeply involved with the quality aspect of it. SolidWorks, Excel, of course, yes, I got very proficient in those through doing, because I was all used to Creo prior, right? But the SolidWorks, after I started using it, I realized it's a lot better, like a lot more user-friendly. So I got really proficient in that, and Excel, and Atos software, which Atos software is the software used for the golem scanner. It's how you create those profile reports and stuff. So I learned a lot about that. I also was able to 3D print one model, but I used a plastic printer just because, money, it's cheaper. But I learned how to upload, slice models, this and that, how to create and design a model for purposes of inspection. And above all else, everyone at Oerlikon was super, super nice. I mean, like, you couldn't ask for a better group of people. They told me the first day that I got there, they're like, whatever you feel like, just know there is no such thing as a stupid question. So if you don't know something, feel free to ask. If they give you grief about it, come and talk to me. And that was one of the managers talking to me within the first week of me being there. That was just awesome. And they stuck to it like the entire way through. I never had an issue with anyone being like, condescending or saying like, that's a dumb question, this and that. Everyone was always more than happy to help out in whatever you were doing or share their knowledge. So I really, really love that about them. I really recommend this company to anyone looking for, any undergraduate looking for some kind of internship or co-op and is interested in automotive or aerospace industries. Life lessons that I learned every day: had to be at work at 8 a.m. sharp for a meeting. We had a floor meeting every single day, so if you weren't there, it was very obvious that you weren't there. And it probably happened like twice. No one says anything really, because I mean, it's just more expected. Just don't make it become like a routine. But I learned about having to work that grind from 8 to 5 every day, learn social skills, because even though we're in engineering and all, and it's not really thought of as somewhere where you have to do a lot of talking, it really is. I mean, there's talking that goes along with every single step of an engineering process. And I learned that everything in an engineering process takes twice as long. So if you think that Like you build a file, like a CAD model, you print it and all. It's not like you just print it and then boom, you're done with your job, like send it to the customer and let's make money. No, you have to like make sure it's abiding by all of the standards, by all the specs, making sure that it's of the best quality that the customer can ask for, and making sure that you meet a specific deadline. Like all of those things weigh in, and it makes literally whatever engineering problem you're working on take twice as long. So that's where I learned patience. Lots of patience. But it was all worth it, and it was really, really fun. And yeah, that's it. Thank you guys. Here's phone. I don't have my work email anymore. That's gone. But here's my school email, position title, engineer, and here's me. So, yep. Thanks, guys. Bye.